All right, the last thing we're going to talk about in this section is piecewise functions. And piecewise functions are a little bit tricky when you first get started on them, but after you do a few of them, it's really not that bad. And the idea of a piecewise is you use one function for a range of x's and you use a different function for another range. So like perhaps you have one function that works for negative values, but you have a different function that works for positive values. So you have two different pieces that make one graph. All right, and here's an example. We have f of x, and that bracket means it's one function or the other, and to the right of that has for the specific values of x. All right, so what it means is use that function when x is negative or 0, and use the other function when x is positive or greater than 0. Okay, so we're going to take the time to graph this. All right, so usually what I like to do is kind of make myself, and you should be doing these graphs in pencil for sure. What I like to do is I like to put like an imaginary temporary line right at that border, the border of the two functions, which is 0. Because I know I'm going to have function number 1 on that side and function number 2 on that side. All right, so when x is less than or equal to 0, I'm going to use that first function, and it's going to look like that right there. Make sure you include the arrow on the end, because otherwise it looks like it just starts at a specific point. All right, then once you hit 0, you use the second function, and that's going to look like this. Okay, now you need to include a filled circle and an empty circle depending on which one is inclusive and which one is not. All right, so the bottom one is inclusive, and that gets a filled circle. The top one is not inclusive, so it gets an open circle. And that's the graph. All right, let's try another one. Now our border value is at -1. So I would start by drawing a temporary line at the border, just like that. All right, and also until you get pretty good at these, what I would do is I would draw the full function and then erase the parts that you don't use. All right, so I would graph that top line, x plus 3, just like that. And I would graph x squared plus 1, just like that. And then I would erase the pieces that I don't use. Okay, so I'm using that top function for everything less than 1, less than -1. So this I'm keeping, that I'm getting rid of. For the other one, I'm using x squared plus 1 for everything greater than -1. So I have to erase this piece. All right, now since they both end up at that same spot, you can put a point there and you don't have to worry about the open or close, because one way or the other, and in this case it's the blue graph, includes that point. Okay, so that's how you do a piecewise function. I'd like to do just one more example. All right, so let's do this. Let's do f of x equals, I'm going to do 3 of them this time, -x minus 4, 1/2 x minus 1, and 2 minus x squared. All right, the first one for x less than -2. Dang it. Doesn't want to draw. Second one, x is between -2 and 2. And the last one is x is greater than 2. All right, so the two border values that I'll use a highlighter here, right there and there. All right, so I'm using this equation here, this equation in this region, and the last one over here. -x minus 4. Okay, so -4 is right there. -x tells me that it's going to be going up like that. And of course, I don't need that part of it. 1/2 x minus 1. My intercept is right there. I'm going down 1 over 2, down 1 over 2. So now it's looking like that. They both touch right there, so I don't have to worry about an open circle, filled circle. And lastly, I have 2 minus x squared. So there's 2. And it would look like this. Oops. Except I do not need that part. So I got to be a little more careful right at that joint there. It includes there. It does not include that one. So that is what my graph looks like. And that's how you do piecewise function. Adios, muchachos.